Don't stop the physics tonight. Okay, so this is Unit 6, problem 5.4, more forces, F equals ma. What we have in this problem is the net force acting on a boat causes it to accelerate at 1.55 meters per second squared. So that's an acceleration. The mass of the boat is 215 kilograms. So there's our mass. And we're looking for a net force here, right? The same net force causes another boat to accelerate at 0.125 meters per second squared. What's the mass of the second boat? Okay, so we'll call this F, A1 and M1, and this will be A2 and M2. So what we're trying to do is we're trying to find the mass of the second boat. So the mass of the second boat, if we had the amount of force acting on it, we could say that the mass of the second boat times the second boat's acceleration, well, we could solve for M here. But we need this net force, and that net force is the same as the first boat. So if we go back to our first boat here, we can say that the net force acting for our first boat, which is the same net force on our second boat, is the mass of the first boat times the first boat's acceleration. And that would just be 215 kilograms times an acceleration of 1.55 meters per second squared. So our F net here, or the total net force acting on our boat, is 215 times 1.55, which gives us 333 and a quarter, 0.25 newtons. So we'll take this number, we'll shove it down here, and down here what we'll see is that we're going to have 335.25 equals mass 2 times the acceleration of 0.125 meters per second squared. If we simply divide by the 0.125 on each side, we're going to get our second mass, and that mass is going to be equal to, oh, it's a doozy, 2,666 kilograms. So that's a big boat, okay? Now what we're going to do is we're going to take our really big boat and we're going to put our little boat on top of it. And then we're going to use the same force applied and say, what's the total acceleration now? So in this problem, we're still doing, the sum of the forces equals ma here. But in this case, while our sum of the forces is still this 333 newtons, 0.25 if you want, whatever, it's going to equal the total mass. So it's going to equal the 2,666 plus the mass of the first boat, which was just 215 kilograms. And then we're solving for a new acceleration here. We're solving for this acceleration at the end of that. So if we do this, we can pretty much see how the math is going to go here, but we're going to have 333 equals whatever the addition of that is. So 266 plus 215 is 2881 times the acceleration. We'll just divide by 2881 on each side. And we'll find that the acceleration here is 0.116 meters per second squared. Maybe you just say it's 0.12 if you're rounding. Okay, and that makes sense because it has to be a number less than before. It couldn't be anything more than the 0.125 because we made this boat even more massive. So it's this motor, whatever's driving it at the 333 newtons, it's not going to be able to accelerate as much. We get something a little bit less than before for that. So not too bad of a problem. We're still just using F equals ma. In this case, we kind of had to find some stuff first to use it in the second piece down here. But in the end, it was just an F equals ma. It wasn't too bad. Just make sure you're being careful with your addition and your division. And whenever we combined the two objects together, we had to add the masses up because they just became bigger. Okay, we got a more massive object there. There are two objects. So making sure you do that is a big part of this problem. Okay, so that's how we do the 5.4 problem. The 5.11 problem coming up next is a little bit tricky, so we'll walk through that, and then we'll see the A4 after that for these C1s. But for right now, we're finished. Adios, and y'all take it easy.